Okay, so when I was growing up and going to grade school, when I would get sick and I would have to come home and not go to school, one of the things I would do was watch a lot of daytime TV. And one of my favorite shows to watch was The Price is Right. I loved the show. It had all kinds of games that people were playing. It had bright colors and loud noises, and people were winning cars and stuff like that. It was awesome. Plinko, exactly. One of my favorites. Right. And as I'm sure everyone knows, Drew Carey is now the host of The Price is Right, but I grew up with Bob Barker, so he's who I will forever associate with The Price is Right. So it was one of my favorite shows growing up, and what I'm going to try to do today is something a little bit unusual, in that I'm going to try to use The Price is Right to help explain how climate change is going to affect reptiles and amphibians. Okay? So bear with me. But first things first. Global warming is happening, and it's going to continue happening into the future as we keep pumping more and more fossil fuels into the atmosphere. What you're looking at here is a map of the world from NASA, and what they did was compile data over the last 4 years of temperatures across the world, and what you see is if it's yellow or red, that means those are places where it's been above average temperatures over the last 4 years. And you can see that, and the more red, the more warming there is. Okay? And you can see there are some patterns where, especially the high northern latitudes up towards the North Pole, have warmed considerably more than other parts of the Earth. But bottom line is that the Earth is warming. And reptiles and amphibians are what we call ectotherms. Does anyone know what an ectotherm is? Any idea?
They need moist environments.
Not for moisture. No. So ectotherm is another word that means, has anyone heard of cold-blooded? Okay, so ectotherm is the scientific term for cold-blooded. And basically what that means is that reptiles and amphibians don't produce their own body heat like you and I do. We're called endotherms, and our bodies produce the heat that we need. Reptiles and amphibians get the heat that they need from their environment, from the air temperature, from the sun. So, given that the climate is warming, and that reptiles and amphibians depend on the climate for the warmth, you might expect that global warming is going to have an impact. And the question is, well, I'll tell you what the question is. How will global warming affect reptiles and amphibians? What would be really nice if there was something inherent in the biology of reptiles and amphibians that we could use to sort of give us some sort of clue about what the effects of warming are going to be. Here's where I'm going to introduce The Price is Right. And specifically, I'm going to introduce one game from The Price is Right. And that game is Cliffhangers. Does anyone recognize the game Cliffhangers? Yeah. We know this game, right? So I'll go over it briefly for those of you who maybe need a refresher or have never seen this before. Cliffhangers, we have a mountain, and it has a very sort of shallow slope going up to the mountain peak. And then there's a big cliff right here at the end of the mountain. And we have a mountain climber. And the game is people are up there and they're shown 3 household items like, I don't know, Brillo pads and a blender and a waffle maker. And they have to guess what the price of those different items are. And if they get the price wrong, the mountain climber takes 1 step up the mountain for each dollar that they're off. Okay? Now, what you want is for the mountain climber to stay on the mountain. Because the further he goes up the mountain, the closer he gets to this cliff. Nobody wants to fall off the cliff, right? Yep. Not only does the mountain climber, well, he falls off the cliff, and you don't win the prize if you're playing that game. So let's just take a look real quick at what happens to the mountain climber if someone makes a terrible decision. It's going up the mountain, still going. It's not looking good. Ouch. Okay, so that's the cliffhanger. And I'm sure you're wondering. I'm sure you're wondering, what does that have to do with climate change and reptiles and amphibians? Well, here's why. And again, I'm going to have to tell you what this is. the physiological health of reptiles and amphibians depends on what their body temperature is. And there's a particular form that that relationship between temperature and health takes. And it looks like this. So we have body temperature on this axis, and we have physiological rate, which is basically physiological health. Right? Physiology is what keeps us alive. It's what allows you to survive. It's what allows you to reproduce. And those are the things that populations of reptiles and amphibians need to do if they're going to be. Okay? And we call this in biology, we call this a thermal performance curve. And you might note that a thermal performance curve looks very similar to the cliffhanger mountain. And it turns out that the cliffhanger game and thermal performance curves have a lot more in common than just their general shape. And I'll get to that in a moment, and it has to do with the cliff at the end. Okay? So because this thermal performance curve looks a lot like the cliffhanger mountain, we're gonna rename this Mount Physiology for this time. Okay? We're gonna talk about reptiles and amphibians on Mount Physiology. So, what is it about Mount Physiology and climate change that we can use to understand the effects of warming? Well, it turns out that if you're a reptile or amphibian, you want to be at a body temperature that puts you on the peak of Mount Physiology, right? You want to be able to have, if you need to, have the highest rates of physiological processes to keep yourself alive.
Because you're winning, right?
Because you're winning the game, right? So, most reptiles and amphibians in their natural environments have body temperatures that put them about on the peak of Mount Physiology. Now, what if the climate were to change? And in doing the temperature change, and that would, because reptiles and amphibians are dependent on the environment for the heat, that would change the body temperature of this lizard that we have here. Let's imagine it got colder. What if it got colder by, let's say 4 degrees Celsius? Well, it would move down the mountain, right? Its physiological rates or its physiological health would decrease. And that's not great, right? But let's think about what would happen if the temperature increased 4 degrees Celsius. So the same amount of temperature change, but it's an increase instead of a decrease. That's what happens. So the shape of this Mount Physiology means that it is inherently worse for reptiles and amphibians to get warmer than it is for them to get colder. Okay? And yes?
How do we know that the current reptile population is at the peak of Mount Physiology like
Because
that?
we measure. And I'll get to that in a second. I have the data. This should be sort of, I mean, this is not good to begin with, right? It's inherently worse to get warmer, and we know that the Earth is getting warmer. So I'll show you an example of how we can use this idea of Mount Physiology to actually predict for a real Earth what's going to happen with climate change. And I'll use an example from my own research. So I do a lot of research in Puerto Rico on the lizards there, and one of my study organisms is this lizard right here, Anolis cristatalis. This is a small lizard. They're about this long. They live in trees, and they're all over the island in Puerto Rico. And one of their favorite habitats to live in is this it's sort of hard to see from the picture, but this is sort of like desert scrubland. There are some cacti in there, and it's like relatively low, scrubby trees. And these guys are running all over the place in there. And I was interested in how global warming might affect these populations of lizards in this habitat. So you need 3 things if you're going to figure out the effect of warming. One, you need to know what the temperatures of the lizards are now in that habitat. You need to have an estimate of how the temperature in that location is going to change as warming continues. And you have to have Mount Physiology for this lizard. You have to be able to estimate that. So I went down to Puerto Rico, and I measured body temperatures of hundreds of lizards in this habitat. And if you're wondering how you measure the body temperature of the lizards, I can tell you do it the old-fashioned way, like your grandpappy used to do. So we also know, so we have projections. People have been modeling how the climate for a long time, and we have projections of what it's going to be in Puerto Rico about 100 years from now. And it's going to be about 3 degrees Celsius warmer there now, in the future than it is right now. Okay? So we have an estimate of what the temperatures are going to be there. And we can estimate how their body temperatures are going to change. The next thing we need to be able to estimate is mountain physiology for this species. And to do that, I measured their sprint speeds. So basically what I did was I went out and I caught a bunch of these lizards. And I set up a ramp. And I run them on this ramp and I measure how fast they run. And I do this at a bunch of different temperatures. So that will give me that curve. So how their physiological rates are changing. This is just a slow motion video of a lizard running on the ramp. There it goes. That's in slow motion, about a quarter of the actual speed, so they're pretty fast. And with these sprint data, okay, here's mountain physiology for another species. Now, where would you guess their average body temperature is? Where would it put them on this mountain? Sorry?
33 degrees.
33 degrees. That is an amazingly accurate guess. You would expect them to be about at the peak of mountain physiology, and that's actually where they are when you do the measurements. Okay? So now, we know where they are now, and we can predict what their body temperatures are going to be given the 3 degrees Celsius increase in air temperature. And here's what happens. These lizards fall off the cliff. They fall off of mountain physiology. And in fact, their physiological health is predicted to be decreased by over 30% with just a 3 degrees Celsius increase in temperature. Not a very big increase, but a huge detriment to their health as a result of that warming. Okay, so here's an example of, in principle, how you can use this, actually look into the future and think about how warming is going to affect the population. Let's think about it on a global scale now. I'll go back to the map that I showed you before of how temperatures are changing in different parts of the world. And as I said, temperatures are warming faster in the high northern latitudes, and they're warming in the tropics, but less so. So where do you think the impacts of warming would be the most acute? Where would be the greatest impact of warming on reptiles and amphibians? I hear the poles. So yeah, right, you had the most warming up here. So you would expect that the greatest detriment to reptiles and amphibians would be to those populations that live in those areas of the world. Well, it turns out that people have been measuring thermal performance curves and measuring mountain physiology for a number of different species all over the world for years. And a couple of years ago, a bunch of researchers got together, and they put together all these performance curves, and they looked at what the temperatures are of those lizards, of those populations now, and then they projected ahead with how much warming is expected at each one of those places that they're from across the world. So they can specifically ask, is it true that you actually have the worst effects of warming in the places where warming is the greatest? And it turns out that intuition is not correct. The greatest effects of warming, so let me explain this graph. The color indicates what the impact of warming will be on their herps in that particular location on the globe. The more blue, the worse the impact. And we can see it's the most blue in the tropics. So although there hasn't been as much warming and there isn't going to be as much warming in the tropics, the impact of that warming is greater than it is at higher latitudes. Okay? Now this is bad because most herps in the world live in the tropics, by far. Most herps in the world live in the tropics. Okay? So why is this? How is it that the place with the most warming doesn't have the greatest impact on the herps living there? And to resolve this paradox, we'll go back to the mountain physiology. And it turns out, like Anolis chrysotellus that I showed you before, if you look at tropical herps, almost all of them are on the top of mountain physiology, on that peak. Okay? However, it turns out that temperate lizards and herps in general, which are in the minority, but temperate herps, actually tend to be a little bit further down the mountain, down this physiological mountain. Their body temperatures on average are a little bit below the peak. What that means is that tropical herps are closer to the cliff. They're closer to falling off that cliff. So a smaller amount of warming has a bigger effect. Okay? So, when you're thinking about herps and climate change, just remember that the price is wrong. All right, thank you.